Okay, quadratics review. Number one, the number of segments connecting non-adjacent vertices in an n-gon can be found using a quadratic equation. So you know it's going to be quadratic. This is a little confusing. Connecting non-adjacent vertices, meaning they are the ones that are not next together. So I would connect this to the other side because those are non-adjacent. This one is adjacent to that one. So this polygon would have two diagonals. So 4 sides, number of diagonals 2. Here I would have 1, 2, 3, 4, 5, and that one's it. So 5 diagonals, and there are 5 sides there. And this one has 1, 2, 3, 4, 5, 6 sided figure. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's all of them. So 9. So I have these points, and it looks like I'm missing some things, but I'm not going to be able to figure that out unless I either draw them or figure out the equation and then use the equation to find these missing sides. So I'm going to use the equation. Go to Stat, Edit, put these in the x values. These are basically your x's and these are your y's. 4, 5, 6, and then 2, 5, 9. Stat, calc, and we already know it's a quadratic from this. So you hit that, and you can hit vars, y vars, function y1. This is going to make sure it looks like this. This allows you to take this and it puts it in y1 automatically. So you don't have to do any of that work. That looks a little crazy, but it's the same thing as this. So let's see. So to find these missing pieces, I need to go where x equals 10, and then all the way up to x equals 100, and somewhere where y equals 1080. So I'm probably going to do this. I'm going to choose a window somewhere between 4, because I don't need anything below that, or maybe even 3. That would be a triangle. You can't go less than that. So all the way up to, we'll do 100. And then that's when you're allowed to do zoom fit, only after you've chosen the domain. Hit zoom fit, let it graph. I'm going to hit trace. I'm going to go when x equals 10. When x equals 10, there are 35. When x equals 100, there are 4,850 diagonals. And when will this equal 1080? Somewhere here. I'm going to set y2 equal to 1080. Graph it and find the intersection there. .48. All based on that equation. So the actual equation I didn't write down was y equals 0.5x squared minus 1.5x plus 0. Now, a lot of you will write the plus 0, and it's okay to write that, but you also don't actually need that. So I'm going to leave that off. Let's see. Next one. What is the concavity of the graph? Okay, this is something that a lot of you have trouble with. Now, just looking at the graph, this is concave up. So I already know it's concave up. But in Precal, we need a justification that has to do with rate of change. So what I need to do is I need to find 2 points. I'll just use, I don't know, let's pick these 2 points. So 6, 9, and point 10, 35. Find the rate of change. 35 minus 9. 10 minus 6. And I'm going to get 26 over 4. .5. Okay. The units, diagonals per side. Now this is actually going to change because as the graph moves on to the right, the rate of change is going to increase. So what I'm going to do is I'm also going to pick another set of points, let's say right next to it, and do the rate of change between those. So between 1035 and 48, 1080. So rate of change between there, 1080 minus 35, 48 minus 10. See, 1080 minus 35, that's 1045 over 38. So as you can see, as you get more and more sides, you add on more and more diagonals at a faster rate. So you're getting more diagonals per side as you add more and more sides. So the justification here has to do with that it's concave up because the rate of change increases. That's the key part, is that the rate of change is increasing.